shape transformation process of a material. Force applied causes deformation in the object. It changes the relative positions of constituent particles in the crystal lattice. As soon as that happens, the interatomic or intermolecular forces come into play, and then they tend to restore the solid back to its original shape. This restoring force per unit area is called stress. When external forces are removed, the internal force tends to restore the solid back. This property is called elasticity. However, no material is perfectly elastic. And what happens is that the body is not able to restore itself completely. Six different processes. First process, forming process. Forming or metal forming is a metalworking process of fashioning material parts and objects through mechanical deformation. The workpiece is reshaped without adding or removing material, and its mass remains unchanged. Forming operates on the materials science principle of elastic deformation, where the physical shape of a material is permanently deformed. Example: exterior car body components. As we can see, some components, hoods, bumpers, fenders, doors. Hydroforming process. Hydroforming process is a cost-effective way of shaping ductile metals such as aluminum, brass, low alloy steel, and stainless steel into lightweight, structurally stiff and strong pieces. One of the largest applications of hydroforming is the automotive industry, which makes use of the complex shapes made possible by hydroforming to produce stronger, lighter, and more rigid unibody structures for vehicles. This technique is particularly popular with the high-end sports car industry and is also frequently employed in the shaping of aluminum tubes for vehicle frames. An example is automotive industry with either high or low pressure methods. As we can see in the image how this process works. Third process, forging process. Forging is a manufacturing process involving the shaping of a material, of a metal, using localized compressive forces. The blows are delivered with a hammer, often a power hammer, or a die. Forging is often classified according with the temperature at which it is performed. Cold forging, a type of cold working, warm forging, or hot forging, a type of hot working. For the latter two, the metal is heated, usually in a furnace. Forged parts can be ranged in weight from less than a kilogram to hundreds of metric tons. Forging has been done by smiths for millennia. The traditional products were kitchenware, hardware, hand tools, edged weapons, gimbals, and jewelry. Since the Industrial Revolution, forged parts are widely used in mechanisms and machines wherever as a component requires high strength. Such forgings usually require further processing, such as a mechanism, to achieve a finished part. Today, forging is a major worldwide industry. As example, in the image we can see sliders, pliers, hammers, wrenches, and garden tools, as well as wire, rope clips, sockets, hooks, turnbuckles, and eye bolts are common examples. Extrusion process. Extrusion process is a process used to create objects of fixed cross-sectional profile. A material is pushed through a die of the desired cross-section. The two main advantages of this process over the manufacturing process are its ability to create very complex cross-sections and to work materials that are brittle because the material only encounters compressive and shear stresses. It also forms parts with an excellent surface finish. An example, we have trim parts as used in automobile and construction equipment, railings, window frame members, and structural parts, etc. We have an image where we can see how this process works. Punching process. Punching is a forming process that uses a punch stress to force a tool, called a punch, through the workpiece to create a hole via shearing. Punching is applicable to a wide variety of materials that come in sheet form, including sheet metal, paper, vulcanized fiber, and some forms of plastic sheet. The punch often passes through the work into a die. A scrap slug from the hole is deposited into the die. In the process, depending on the metal being punched, this slug may be recycled and reused or discarded. an example. In the image we can see how this process works. The punch crosses the sheet metal piece, giving us blanking, scrap, and the workpiece blank. And this is commonly used in automobile industries, aerospace industries, kitchen appliances, mass production of sheet metal components. Stamping process. Stamping, also known as pressing, is the process of placing flat sheet metal in either blank or coil form into a stamping press, where tool and die surface forms the metal into a net shape. Stamping includes a variety of metal sheet forming manufacturing process, such as a punching using a machine press or stamping press, blanking, embossing, bending, flanging, and coining. This could be a single stage operation where every stroke of the press produces the desired form on the sheet metal part, or could occur through a series of stages. The process is usually carried out on sheet metal, but can also be used on other materials, such as polystyrene. Stamping is usually done on cold metal sheet. Examples: metal stamping can be used or applied to a variety of materials based on their unique metalworking qualities for a number of applications across a wide range of industries. Metal shaping may require the forming and processing of based common metals to rare alloys for their application-specific advantages. Some industries require the electrical or thermal conductivity of beryllium copper in areas such as aerospace, electrical, and the defense industry, or the heat-strength application of steel, and its many alloys for the automotive industry. That's all from my part. Thanks for watching the video.